Good morning, boys and girls, and welcome to another episode of Pep's Corner. Today we will continue reading our book and finish our book, The Sun. Our focus is posted on the screen. We are still in week 12. We are on day 4. We will be reading from pages 16 through 26, which will be the end of the book. So go ahead, make sure you have your book in hand and are actively following along and reading. Remember, boys and girls, to reread a second time so you are coming to shared reading, fully prepared to engage in instruction and discussion. Let's begin. Page 16. The sun is never at rest. Sometimes giant storms called sunspots erupt on the surface. These storms look like dark spots or blotches. The line of sunspots in the lower part of this photograph is a storm 100,000 miles across, 12 times wider than Earth. Sunspots send powerful streams of electric energy into space. The energy released in 1 hour by this storm is equal to all of the electrical power that probably will be used in the United States over the next million years. The numbers of sunspots change over an 11-year period called the sunspot cycle. During a year when the sun is quiet, large sunspots appear very rarely. During a year when the sun is active, as many as 100 large sunspots appear. The next peak in the sunspot cycle should occur about 1991. What causes sunspots? Scientists are not exactly sure. They do know that the sun is like a giant magnet with north and south magnetic poles. Scientists think that sunspots occur when powerful magnetic storms break out on the sun's surface and prevent some heat and light from escaping. That's why the spots are darker than their surroundings. This photo shows two views of the same sunspot activity. The picture on the bottom is called the magnetogram. It shows that each pair of sunspots has both a north and south pole. A magnetic force over 1,000 times stronger than normal runs between them and stretches in a loop up into the sun's atmosphere. The magnetic forces erupting out of the sunspots sometimes carry hot gases within them. These flaming streams of gas are called prominences. Traveling at speeds of 200 miles per second, prominences arch up through the sun's atmosphere. Some prominences fly off into space, but most loop back to the sun. Many prominences are over 100,000 miles long and 3,000 miles thick, yet they can rise and fall in just a few hours. Other prominences last for days or even weeks. This photograph shows the magnetic loops that carry the hot gases of prominences. Sometimes the magnetic forces in a large sunspot are released in fiery explosions called flares. Flares last for only a few minutes, yet they have the power of 10 million hydrogen bombs. These violent explosions send out waves of intense heat, light, and radiation. When this radiation hits Earth a few hours later, it can black out communications and cause magnetic compasses on airplanes and ships to spin wildly for a short time. Flares also send out great numbers of tiny particles out into space. Some of these particles reach Earth and become trapped in Earth's magnetic field near the north and south poles. As these particles come down through our atmosphere, they make the air glow in shimmering multicolored curtains of light called auroras. In the north, this is called the aurora borealis, or northern lights. In the south, it is called the aurora australis, or southern lights. The sun is all important to life on Earth. Our weather and climate depend on the sun. Green plants need sunlight to grow. Animals eat plants or food, and we need plants and animals to live. Even the fuels we use, such as coal, oil, and gases, are the remains of once living things. Without the sun, there would be no heat, no light, no clouds, no rain, no living thing on Earth.